Good day, everyone. To solve for literal equations, we just simply need to follow the steps or the processes in solving linear equations. But instead of finding out the values for the intended variable, we're just going to manipulate, or in other words, derive the given literal equations into an equivalent form wherein our intended variable is placed on one side of the equation, or that is only the item that we're looking for. Say for example, for number one, we this is the formula for the area of a rectangle. The area of a rectangle is the product of the length and width. However, if the area is given but the width is not, we could come up with an equivalent literal equation or derivation of this formula wherein the measurement of the width, or the W, is what we have here on the left hand side of the equation. So to do this, let us start to examine the operation separating the variables length and width, or L and W. Since these two are separated by multiplication, then we are just simply going to use the opposite operation. Take note, this is similar to the situation under the linear equation, which is actually in this form. 8 is equal to 2x. And we are going to solve for the value of the variable x. The operation separating 2 and x here is multiplication. That is why when we solved this before, we divide here by 2, so we can cancel it out, and we are left with x here. This property will also allow us to divide 2 on the other side. This will actually result to 4 is equal to x. And just for a formal presentation, we could apply the symmetric property to interchange the 2 without changing the values of the coefficients or the terms. Then we have here x is equal to 4. So we are going to do the same process here. Again, the operation separating the length and width is multiplication, and as therefore we are going to divide both sides by L. We are going to divide both sides by L so that we could actually cancel this out, and what remains here is actually the W, the item we're looking for. Again, divide both sides by L. So our next expression here is we have A over L is equal to W. And again, we could apply the symmetric property to say that W is equal to the quotient of A and L. Before we could proceed to the next example, there is a important concept here that needs to be followed. If the given here for the variables are in uppercase, such as for the area, a capital letter A, it should stay as a capital letter in our derivation. If the given notations for the variables are in lowercase or small letters, just like the L and the W, it should stay as it is so that we are not changing the expression. The reason behind this is that there are plenty of literal equations. As we all know in our module, literal equations are also uh, defined as formulas. There are plenty of formulas wherein in a specific formula, we could see an upper and lower case of a letter. If we are going to just simply use all upper cases or capital letters without considering that some of them are actually given as lowercase or small letters, we are actually changing the whole literal equation. So again, please be reminded that if the variable a here in the given is an uppercase or a capital letter, it should stay as a capital letter. The L should stay as a lowercase or a small letter, as well as W. So let's try to proceed to number 2 and look for the equivalent expression for S. This is the formula for the perimeter of a square, which is perimeter is equal to 4 times S. But we are not looking for the perimeter, we're looking for S. To do this, simply apply what was done in number 1. Divide both sides by 4 so that S will remain here. Again, both sides. And then you have here P over 4 is actually equal to S. Applying the symmetric property, you have S is equal to P over 4. Again, as a reminder, P is in uppercase or capital letter, H should stay as a capital letter, and S should stay as a small letter. Again, so that we could not change, we will not be changing the expression or the literal equation itself. So number 1 and number 2 are done like this. For number 3, we'll just simply do the same process, even if we have here 3 variables on your right hand side of the equation. In the right hand side of this little equation is actually the formula for the volume of a rectangular prism. Volume is equal to the product of length, width, and height. There are many little equations that are actually given already as um, formulas, but you can also make up your own little equations, like what I did in number 4. This is actually a made up little equation just to support a discussion for this practice exercise. So again, let's go back to number 3. We are looking for H. A derivation of this formula we're in, H is what we're looking for, and not the volume. So to do this, again, we divide both sides by L so that we can remove your L, and also the W, or the width. We also divide it both sides, and the other side rather. We'll try our best to make sure that small letters shall retain as small letters. And after that, you will have here the volume is equal to, volume over length times width is equal to height. And by symmetric property, you can say H, or the height, is equal to volume over the length and the width. So this is a derivation for little equation number 3. And finally, we could use here the same process as in number 4. Okay. So in number 4, we're looking for C. This is what we're looking for. So since C is located here on the right-hand side of the equation, we remove the other coefficients here, which are 4 and D. And since all these 3 coefficients are separated in multiplication, we still resort to dividing both sides by 4 and D. So 4 could be removed and D could be removed. Apply it on the other side as well. So you have AB is equal to 4D. That's your C. Again, this is already acceptable, but to make it more formal, let's apply the symmetric property, interchanging both sides without changing the signs nor the values of the expression. So you have C is equal to AB over 4D. So this is how we solve for the given, for the unknown, or not unknown, the intended variables for these 4 literal equations. And notice that these 4 literal equations uses the same concern, wherein the on one side of the equation, the given operation separating the coefficients or the variables are in the form of multiplication. It's like here, here, even here, and even in number 4, both sides enjoys the process of multiplication. Before we will end the presentation here, we could apply here one technique as well. This technique is called to be the magic triangle. This is not new probably to some of us because you might have been using them in other subject areas, right? So we have here the magic triangle. As a reminder, magic triangle is only possible for literal equations enjoying the operation of multiplication as a separator on either of the sides. If one side or both sides of the literal equation um, has a separator in terms of addition or subtraction, then we cannot use the magic triangle. Again, we could only use magic triangle to little equation similar to items given here. The magic triangle is, of course, a triangle wherein we simply place right, the given literal equation here. The upper portion of the magic triangle is your left hand side, and the lower portion is your right hand side of the equation. Again, left hand side of the equation and right hand side of the equation, four literal equations enjoying multiplication as a separator on either of the sides. So we place here for, let's try for number one, the left hand side of the equation is a, and the right hand side is length and width. The application of the magic triangle follows the concept that the intended variable you're looking for is the variable you're going to hide here. Hide or cover. To do that, let's try to cover the intended variable w here. So let me select an area here and let me copy it. And I will just be covering the w. Why w? Because that's the intended variable. That's the step for the magic triangle. I only cover the w because that's what we want. The remaining variables or coefficients are your result. You have A and L. And what do you think will separate them? Here's the concept for the magic triangle. As you go from top to bottom, you will use the operation of division. As you go from left to right, you will use the operation multiplication. So since the variables left after covering W is A and L, up to from top to bottom, we'll use division. The result here for W is A over L. As you can see, using the magic triangle and uh, the process here involve the processes involving, as you can see, the result under the magic triangle, and by following the process of solving linear equations before, we arrive with the same answer. Let's try to use the same magic triangle here for number two. And let's try to place again, the top should be your left hand side, which is P, and the bottom is your right hand side, which is 4, and then S. Since we would like for S, let's try to copy, let's try to cover rather, the S. Again, because S is what we want here, let's try to cover S. What remains here is P and 4. Again, from top to bottom, we will use division. Therefore, the value for S is P divided by 4, which is again similar to the process earlier. Proceeding to number 3, another magic triangle here. But since the right hand side has three variables, we place all three variables here. So for the top, V, you have L, W, and H. And we would like to solve for H. So we cover here H. Just cover H. What remains is the V over L and W. Again, from top to bottom, you will apply the division. So the result for H using the magic triangle is V over L and W. Again, similar to this process. Even if in number 4, wherein we have two variables in your left hand side rather, you simply place them here still. So the upper portion of your magic triangle will contain A and B because those are the variables found in your left hand side, and your lower portion shall contain for C and D, which are actually the variables in your right hand side. And since we would like for C, let's cover C. Let's try to cover C, and we have that. So from top to bottom, we will use division. So since AB, again, similar here is multiplication, so we simply copy that one. So C is equal to AB over, from left to right, as a reminder, from left to right, we will use multiplication. So we simply multiply 4 and D, which will actually result to 4D. Examining this result under the magic triangle and the result earlier, we came up with the same answers. So this is just the process application of the magic triangle. You may use the magic triangle. You may use the processes of using the properties of equality. we are um, assured of that they will come up with the same result. But again, this magic triangle is only applicable for literal equations enjoying the operation of multiplication or division on either of the sides. If one side, let's say number 4, if this is a plus b, you may there might be some instances that it's possible, but most of the instances, magic triangle will not be anymore possible. So please um, be guided with that. So these are the results for practice exercise A for lesson number 1. Thank you for watching. See you soon.